Hello, this is Jennifer Martinez. We're going to talk about inverse trig functions. I'm just going to look at the notes from our textbook starting on page 248 from section 6.1. In our textbook, they have a definition in a box called inverse sine function. And what it is, it's y equals sine. This -1 represents inverse of x, or you can call it arc. Either one, it's the same. Y equals arc sine of x. They both mean that x equals sine y. And this is what we're going to talk about today. This is really important, this range. So what is this? Well, if you take our normal y equals sine x and you switch the x and the y, that's our inverse function. And the reason they call it a function, that's important, that means for each x there is only one y. That's what function means. So that's why the range has to be limited. So to show this, let's look at the normal y equals sine of x. Look at the normal y equals sine of x. When you find your inverse, you're just going to flip the x and the y. So this point right here would be 1 comma pi over 2. 0, 0 would be the same thing. And a point in here, like say pi over 6, right? Sine of pi over 6, just plug that in. That would be 1/2. So this point right here now becomes 1/2 comma pi over 6. You can see it right here. It just gets flipped. So this shape will become this shape. And by the way, that is a reflection about the y equals x-axis. It's a mirror image. So if we were to continue on here and keep on doing the points, it would look something like that, sine would. And you can see that this is not a function. For each x, there's more than one y. So they had to stop it. So that's why they took this area right here between the restricted domain and just use that. So sine inverse of x, they're saying, is going to be restricted from -pi/2 to pi/2. That is the y, which is the angle when you're talking about the range of sine inverse. Because 1 over sine is equal to cosecant of x, it is the same for cosecant of x. Minus the 0, because sine of 0, if you take 1 over 0, right, that would be undefined. But essentially, it's going to either be in quadrant 1 or quadrant 4. So here's all the place. So for instance, let's just do an example of this so you can just see it. If I take y equals sine inverse of 1, let's do -1/2. Well, what would that mean? Let's scroll down a little bit. That would mean that sine of what angle equals -1/2. Now, there's more than one answer for the second line. But because we had this inverse, we know that we're restricting it. So what quadrant, again, let me scroll down a little bit more. What quadrant is sine negative? We know it's either in the fourth or the third. But since it's sine inverse, it's only restricted to either fourth or the first, so we now know it's in the fourth. -1/2, we know the y, this is y over x, sorry, y over r. -1, 2, square root of 3, we know that's 30 degrees, or pi over 6, -pi over 6. Because we want to be from -pi/2 to pi/2. So that would be the definition of sine inverse. Now let's move on to cosine inverse. On the other hand, cosine inverse, you'll notice, has a different range. So, but everything else is the same. Y equals cosine inverse of x. The definition written in the book, it's a function. So that means for each x, there's only one y. Y equals arc cosine of x means that x equals cosine of y. Why do we have a different domain, a range, for cosine? Well, let's look down here at this graph, because again, here's our cosine function. So again, we're going to switch this. This would be the point 1, 0. That's why they have 1, 0 here. This would be the point 0 pi over 2, right? And if we did negative pi over 2, 0, this point right here, that would be down here somewhere. The graph would look like with that in the red. And if you notice, that's not a function. Not so good. So what they did is they decided, if you notice this says restricted domain on the graph, they decided to take this bit, 0 to pi. That works better for cosine because it's a 90-degree shift. So, cosine inverse of x, the range goes from, we saw, 0 to pi. That's the range, which is quadrant 1 or quadrant 2. So if we give you an example of that, what if I had cosine inverse of negative 1/2? Let's use that negative 1/2 again. That is equal to some angle, some y or some theta. So if I go by the definition, that means cosine of my y equals negative 1/2. The second line again has more than one answer, but the first line better have one answer since it's a function. And what answer is it? Well, cosine is negative either in quadrant 2 or quadrant 3. But quadrant 3 is not in our range. It has to be between 0 and pi, so it better be in quadrant 2, because quadrant 1 is positive, quadrant 2 it's negative. So we know that this would be negative 1, let's erase that, this would be a 2, this would be a square root of 3. Oh, that looks like a 60-degree or pi over 3 reference angle. But we want to pi minus pi over 3 to get the angle between 0 and pi, right? Because that's the reference angle, 6 degrees right there. So that would be 3 pi over 3 minus pi over 3, which is 2 pi over 3, would be the only answer for this. Again, there's more than one answer for this, but only one answer for cosine inverse. Next is tangent inverse. Tangent inverse, which is very similar. Y equals tan to the negative 1 of x means tan inverse, or you can have y equals arctan of x. It means the x and the y are switched, and it's on a range that is more like sine. Why is that? Well, you can see here from the picture that there's really no problem with tangent between, and so you might as well do in between the two asymptotes. There is not a place where it is undefined, and it looks really nice there. And if you put it to the side, it looks like this. So for tan inverse, the range is going to be the y. It's going to be from negative pi over 2 to pi over 2, like sine inverse. If you want to see an example of that, like for instance, tan negative 1 of negative 1. Well, what does that mean? Let's make that a y. That means that tan of y equals negative 1, which again, there's more than one answer. Tan is negative either in the second or the fourth quadrant. You erase the second because our range is only from negative pi over 2 to pi over 2. Negative 1, 1, square root of 2, that looks like 45 degrees, pi over 4. And since it's negative pi over 2 to pi over 2, I'm just going to say negative pi over 4 instead of saying 2 pi minus pi over 4. So we'll have one answer. Again, more than one answer to this, but only one answer to that because it's a function. That's the definition of function. For each x, there's only one y. Cotangent, finally, is nice between 0 and pi with no asymptotes. So it is different. Cosecant and sine and secant and cosine, those 1/overs have the same quadrants, but y equals cotangent of x, of negative 1 is going to be more like cosine, 0 to pi. You can see an example of that if I do y equals example cotangent negative 1 of negative 1. For cotangent, we would have something a little bit different, because we know that cotangent of that angle is negative 1, is in quadrant 2 or 4 again, is where it's negative. But now, since cotangent between pi over 4, we'll erase this one, and the reference angle is still pi over 4, but this time we're going to take pi minus pi over 4 to get between 0, right? The y is going to be from 0 to pi is the range for cotangent. So you were going to take that and get 4 pi over 4 minus pi over 4, which is 3 pi over 4. Again, there's only one answer, but it would be different than the cotangent inverse. So to summarize this, y equals sine inverse of x, y equals cosecant inverse of x, and y equals tangent of x. All the inverse functions are going to be from quadrant 1 and 4. Whereas y equals cosine inverse x, y equals secant inverse x, and y equals cotangent inverse x are all going to be either in the first or second quadrant. It's supposed to be at 2 because we go from 0 to pi. Granted, there are some values here that are not defined for secant, but regardless, these three will use quadrant 1 and 2, and these three will use quadrant 1 and 4. Positive, negative, and positive, negative. Hope that helps.